This has been one of the hardest and most time-consuming builds I've ever done in my life, but it was also extremely rewarding and I ended up learning a ton. I'm excited to share this process on how I built a scale replica of the Crimson Oak Pond for BamaBass. You will want to stick around because I have a really cool giveaway for this video. Now let's jump into the build. To start this project off, let's first start with how I created a 3D model of the Crimson Oak Pond. The way I did this was to first hop into the USS Sarah and use this non-sketchy setup to drive around the lake in various checkered patterns. The more times you overlap and cross, the more accurate the map will be in the end. I am using the Humminbird brand fish finder, which has a mode called Auto Chart. This will create a 2D map for you at low resolution. Once we got the pond all mapped out, I imported the data into Humminbird software called Auto Chart PC. Within this software, the only thing we could do was increase the resolution of the contour lines, and unfortunately for me, there is no option to export as a 3D body to CAD software. So I did what any sane person would do, and I grabbed a screenshot of the high resolution map and I began tracing each line point by point to generate a contour map in the SVG format. Once we had it in the SVG format, we could then import it into Fusion 360 and begin extruding each layer, and voila, a 3D model of the pond. To build the base of this table, we're going to start off with roughing down this walnut slab. You'll see I am having some problems here since I've never worked with wood this thick. My circular saw could not cut the full depth, so I needed to use the Sawzall to cut all the way through. I cut the walnut into strips using the table saw, and looking back now, this probably wasn't the safest or the best way to do this, but it did work. This is going to be the center section in the base of the table, which is going to be a checkered end grain pattern. I think this is going to look super cool with a fish mount sitting on it. After getting all the end grain pieces cut into strips, I jointed and planed each piece to be flat and square. You can already see the really cool grain pattern showing in these end grain pieces. Here is a neat clip showing you what this process is doing. When laying flat on the table saw, you can easily see the gaps in the bows in the wood. And here's after. Perfectly flat, 90 degrees. It's crazy for me to think that this little part of the project was one of the major reasons for building the chessboard in my previous video. After truing the boards up to their final dimension on the table saw, it was time for the first glue up. And yes, I'm still a big fan of using every single clamp available. Once out of the glue, I flattened one side on the CNC as a reference plane, and then ran through the planer to clean up the other side. I then trimmed off the edges, ran back through the table saw crossways, and then glued it up in a checkerboard pattern. A couple more passes through the planer, and the center section was mostly complete.
Dead nuts flat.
Now, this is only a component of the base. We need to work on creating the edge banding to create a more finished look. We're going to grab some rough 8/4 lumber and run it through the milling process, which includes the joiner, table saw, and planer. Using our now milled lumber, I am meticulously measuring and fitting them around the end grain, sort of like creating a picture frame. This part was very tedious, and I made multiple cuts to make all of the 45-degree fits as tight as possible. I did end up using dowels here to make the glue bond a little bit stronger and to help with the gluing fit up. But I would 10 out of 10 not recommend this cheap dowel centering tool I bought. It was really hard to see the reference line and seemed to always walk away from the center, making the holes not line up. Moving on to gluing these last pieces on the base, and once cured, a final trimming to size. You may have noticed the cracks in the end grain earlier, and I purposely hid all of those on the bottom, but before completing these last few steps of the base, I filled the cracks and any defects with black resin. The goal here was to stabilize any potential defect so that the cracks will not continue to grow in the future. This may seem like a completed table base, but now it's time to get into the more nerve-wracking steps of the project, where any small mishap will cause likely a month or two of delay. So let's take this over to the CNC and try not to mess anything up. Up first is to CNC a pocket out on the bottom. This gives us space to house the electronics that will be used to power all the lights and control the automation. Next, we're going to CNC a recess with internal chamfer edges. This serves two reasons. The first being that I think it just looks plain cool, and the second is we need more internal height clearance to house the tube rim fighting over a worm mount. What made this so nerve-wracking was, remember those dowels I put to help bond the edges to the end grain? Yeah, so if I go a little too deep on the CNC, the dowels would show, and since they're more of a maple pine wood, it would look terrible and basically turn this base into firewood. After that, I really wanted to do an oak inlay into the walnut end grain, and what better logo than the BamaBass logo? So while I had the base up on the CNC, I carved the negative into the end grain and then swapped in a piece of oak and carved the positive. This was incredibly stressful because I've never done an inlay before. Here I am drilling a hole which is a through hole to the electrical pocket. This will be used to pass power to the control board. The last feature before gluing in the oak is to chamfer the outer edges. And I'm going to be honest here, this was sketchy. When I turned this router on with this massive chamfer bit, it sounded like a helicopter about to take off. One last thing to do here is to clean up the edges with a chisel. I somehow missed that the CNC wouldn't leave perfect corners, so this will fix that. Here's a really good shot of both the positive and negative of the BamaBass logo. Now let's glue it in. Dude, that fits perfect. What makes this oak so special, and the reason why I wanted to use it so bad in this project, was it's not just regular red oak from the store. This is the wood from the oak tree that fell on the Crimson Oak farm during the hurricane. This tree used to be exactly where the island currently is in the pond. That is just so cool to me. After the glue dried, I trimmed off with a flush cut saw and quickly flattened using the CNC in manual mode. A little sanding and boom, the base is finally complete. The legs and side pieces were built again from walnut, but not to bore you guys with the same process over and over, we would just quickly cover it. First we take the raw wood, then we run it through the joiner, planer, and table saw. The thing to note here is that the legs are actually two pieces that get glued together. The reason for making them two pieces is because one of the legs we will route a channel through the center of it. That passageway will be how we pass the wires from the tabletop to the electronics at the base. During the glue up, I pushed a rod with napkins at the end to clean up any glue through the passageway. Once the glue dried, I cleaned up the glue squeeze out. I cut them to length, and then the legs that will be holding the large front and back glass panels, I routed a 1/4 inch wide groove for the glass to sit in. On one of the side pieces that will be going on the back, I CNC'd my logo in it and filled it with black resin for a professional look. Once the finish gets applied, I really loved how this turned out. All these highlighted pieces are now complete, so let's start working on the most important piece, the tabletop. I originally intended to use a whole oak slab for the top, but after seeing how warped it got in less than 24 hours after I flattened it, I figured something was wrong. And yep, the wood was nowhere near dry enough to use as a whole slab. While this is a bummer, the walnut slab I ended up using had some insane grain patterns and just looked amazing. So what you're seeing me do is flatten the slab, and I do so by first knocking down the high spots in manual mode. After all the high spots get knocked down, I then let the CNC run a couple complete facing operations. Once I completed this first side, I flipped it over and repeated the process. Doing it on both faces now makes them perfectly flat and parallel to each other, which is going to be very important when we start to carve out the pond. To make sure this table is going to be perfectly square, I ditched the straight edge that I would normally use and bought a track saw. This makes the longer cuts much more precise and repeatable. Now that we have a flat and square tabletop, it is now time to fix its flaws. On the underside of the slab, there was a pretty large crack. Now, I could have just filled it with black resin like the rest of the smaller cracks, but I wanted to try this wood transplant technique. So I programmed the CNC to cut out a rectangle for the entire depth of the crack. Once trimmed out, I was able to quickly cut out another piece of walnut, and the way I got the tightest fit with my transplant piece was to just take off an ever so slightly amount of wood from the sides using a planer. After I got the fit I was looking for, I then filled it with glue and clamped it in place. Using a cutoff saw, I quickly trimmed it to flush with the edge. Now that all the cracks are repaired, I am doing the final facing operations to bring it down to the design thickness. Here's a good shot of the amount of computer interaction it takes to start up this CNC, and this isn't even including the weeks of design work to get to this point. You can really see how well that wood transplant worked in this shot. And I'm curious for the actual woodworkers out there, is this stronger than epoxy or is this the better route? The final CNC work on the bottom is to make some grooves which will give us a nice recess for the LED strips to sit in. Okay, here we go. 5 months worth of work to get to this point, and if I screw up, it's going to be a pretty expensive mistake. If I don't look extremely nervous, well, in this moment I felt like I could throw up. Instead of me just talking, how about we just enjoy this montage of the CNC carving out the pond. Last design to CNC is the Crimson Oak Pond logo. Even at this size, I had to buy a 15-degree V-bit end mill just to get all the detail. Overall, the logo went decently smooth. There was one small error that happened during the tree as the CNC lost track of a few steps. Luckily, we caught it in time for this to still be fixable. Now that we have everything CNC'd, let's get the structure printed before filling the pond with clear epoxy. To do this, I modeled most of the structure using Fusion 360, but for some of the tree models, I saved a little bit of time and just downloaded those. Resin printed works by UV curing, and the UV source is behind an LCD screen that turns its pixels on or off for whichever layer it's on. This project could definitely only be done using resin printing, due to the absolute small size and detail needed. I mean, look at the detail on the Shade Shack. We were able to print those tiny little legs. When resin printing, the fluid is toxic until fully cured. So first, after the print, we clean in an isopropyl alcohol bath, then remove all the supports, and lastly we can put in a UV cure station. Now that the structure is cured, I spray painted them, and then worked on assembling Terry's tunnels and the brush piles. I did FDM print a full-scale pond so I could verify structure dimensions and locations against a real pond. And let me tell you, I referenced a lot of photos. Getting the pond prepped to be filled with epoxy, I drilled some 16-inch holes and started mounting the green LEDs into the pond. For the logo, I went back to that arrow spot and took a chisel and began putting random cuts on the edges to make it seem tree-like. I think this was my only real option here to save it, and in the end, it turned out pretty good. I sealed the logo with some shellac and the pond with some tabletop epoxy. The idea here is to seal the wood to prevent any air bubbles from coming in through the wood. Without doing this step, you run a huge risk of air bubbles in your final pour. While the resin was still wet, I took the time and transferred all the structure from the 3D printed pond to its final home in the table. I am still so impressed with the detail that I was able to achieve with that 3D printer. All the structure just looks perfect. This clip right here really shows the detail of all the pieces before I pour the resin. And you can see the elevation change really good. For the resin pour, I am using liquid glass deep pour. This stuff poured like water, so definitely make sure your workpiece is level. I used the same deep pour resin for the logo, but just tinted black. After letting the epoxy cure for 7 days, I took it back over to the shop for the final facing operation. I know you guys are probably tired of seeing facing operations, but this pond and logo reveal definitely make this one worth it. The last step for the tabletop was to bring the sketchy chamfer bit back out and chamfer the bottom of the tabletop. This was around a 3/4 inch 45-degree chamfer. Now that we have all the pieces finally made, we can now move on to the finish and assembly stage. I am going to skip over the sanding part because it would be pretty boring, but just know there was multiple nights of sanding on all of these pieces. The finish I will be using is Rubio Monocoat. I really like the way this finish came out on the chessboard, and it's extremely easy to apply. The sanding on the tabletop was again multiple days, and as I worked my way through the grits, I would fix any imperfection with black superglue. I started with 80 grit and worked my way to 400 grit. Then I went on to wet sand up to 2000 grit. And lastly, I used various levels of polishing pads until I got to the finest level to give the pond a super clear look. After that, I applied Rubio finish and let everything sit for a few days. I started assembly on the ends first. One side has a glass panel that will get held in place by the routed grooves, and the other side will have a glass door to access the inside of the table. All of the joints have multiple dowels, making them very strong glue joints. While the glue cured, I mounted the fish mount LEDs and soldered on wire for the green lights. Remember, all these wires will get passed down through the leg, which has a hole all the way through it. Now it's time for the big final assembly. This will be 5 months in the making. I first started by dry fitting it until I liked how everything lined up, and then marked the locations and drilled dowel holes. This will again make all of the joints incredibly strong. I did a lot of practice runs for assembling this table because a lot of things had to go right for this to work out great. The most critical parts for this glue up is passing the wires through the leg and not letting any of the glass panels fall and bust on the ground because they're not secured, until the tabletop is in its final place. Last few things to tidy up before taking it out to the Crimson Oak Farms is to mount the electronics and the rubber feet for the bottom. The feet are simply screwed in and are high enough so that the electronics will have airflow to keep them cool. I am using an Arduino Nano here with a couple of solid-state relays and a real-time clock module. Once I get it mounted into the base, I am just tidying up the wires and finishing the terminations, and this table's done. Now before we go deliver this table, let's talk a little bit about this side project I've been working on. So this is almost like a mini copy of the table, but it's going to be something available to purchase for you guys. This is going to be offered on my website, natemakes.shop. And as you can see, it's going to be a charcuterie board that measures 12 inch by 16 inches. It's going to be made from walnut. It's going to have the Crimson Oak Pond CNC to give it a 3D realistic effect, and it's going to be filled with clear resin. It's also going to have the Crimson Oak Pond laser engraved. And as you can see, the top is very, very similar to the table. On the back, we're going to have recessed handles, my logo filled with resin. That way, again, very similar to the table and how I did it on there. And then it'll also have oak inlays on all four sides, which again is very similar to the table and how we did the BamaBass inlay there. This is going to be the same oak from the tree that was on the property. So all of it ties back to the table and back to the farm, and I think it's extremely cool. What it'll come with is it'll come with the charcuterie board, it'll have an acrylic display stand, and you'll also be able to get a coaster of your choice to go with it. You can get the BamaBass logo, the Crimson Oak Pond logo, the Nate Makes logo, and you can also do a 2D contour map of the pond. This will all be handmade and built to order by me. These charcuterie boards take a long time to build. We do understand that this package may be a little high just to the sheer amount of time it takes me to build them. So we're also going to be offering the coasters by themselves, where you can get any of the four logos, whether it be the BamaBass, the Crimson Oak logo, the Nate Makes logo, or the 2D Contour logo. And again, these are going to be available on natemakes.shop. We're also going to be doing a super cool giveaway where I'm going to be giving away a full charcuterie board with the acrylic stand and 4 coasters with each one of the logos. The way you can enter for that giveaway is by going to my website at natemakes.shop and subscribing to our emails. And then from all the subscribers, I will randomly pick one and I'll get this shipped out to you. Good.
Been waiting months to see this one. You ready?
Yeah, let's do it.
Dude, that is absolutely incredible. Oh my goodness. Look at that, we got the oak throne. We got the feed trough. All the wood piles. Look at the tunnels, Terry's tunnels right there. That is absolutely
we actually
incredible.
Built those.
Let me grab the camera for the folks at home. So what do we have here, Nate? Explain that.
These are the LEDs. These match the actual night lights that you have.
Oh my goodness.
So these will light up green once we plug in.
Are they synced up?
They sync up with the actual light. So whenever these come on at night is when these will come on.
Oh my goodness. Look at the topo details down there. See, that's one of the things I love about this is now that the pond's full, you can't see all that structure that we put in.
We even have the last minute prawn pod ad.
Oh yeah, got the prawn pond, shade shack, island, the tunnels, the Terry tunnels. Nate helped me put those back in right before we filled up the pond. And then look at this logo. Man, that is incredible.
But let's not forget about what's going on down here.
Oh yeah, look at this. We got the original BamaBass logo down there.
And so this wood right here is made from the actual oak from the tree that came from that island.
That's our 150-year-old oak that used to sit right out there. It got knocked over by the hurricane, so that's some of that original oak. Nice touch to it. Man, I love it. Works. I like your Nate Makes logo right here on the side.
Yeah.
That is one fine piece of work.
Gotta have a small touch of me.
amazing job. 10 out of 10.
Thank you.
Absolutely love it.